Hi guys, in this tutorial I'm gonna solve question number 4, paper 43, June 19. Two particles A and B of mass 1.3 kilogram, 0.7 kilogram, it's a given, are connected by a light inextensible string which is passing over a smooth fixed pulley. A particle A is 1.75 meter above the floor and the particle B is 1 meter above the floor. The system is released from rest with the string taut and the particles move vertically. When the particles are at the same height, the string breaks. Show that before the string breaks, the magnitude of the acceleration of each particle is 3 and define the tension. This is in general, you have to write equation of particle A, equation of particle B. It's clear that the mass of particle A is more than the mass of particle B. This means particle A move down and the particle B move up. For equation of particle A, move down, weight mg minus tension is equal to ma. For equation of particle B move up, tension minus weight, mg is equal to ma. For mass of the first one, which is 1.3 times 10 minus tension is equal 1.3 times acceleration. For the second equation, tension minus weight, which is 0.7 multiplied by 10 is equal 0.78. By using elimination, by using substitution, by using the division, you can solve these equations to get A and D. If we try to add, you can remove tension with tension. So 1.3 times 10 is 13, 0.7 times 10 is 7, 1.3 plus 0.7, which is 2 acceleration, 13 minus 7, 6 is equal to acceleration. So acceleration 6 divided by 2 is 3 meter per second squared. After finding the acceleration, you can substitute in this equation to get the value of T. Tension minus 0.7 multiplied by 10 is equal to 0.7 multiplied by 3. So the value of tension will be 0.7 times 3 plus 0.7 times 10. So the value of tension is 9.1 Newton. He asked to show that the acceleration is and the tension is equal to 9.1. In part 2, find the difference in times that takes the particles to hit the ground. See, now we'll get all the information before the breaks and after the break. First, start to get the information before the break happens. Let me start with any, let's say, particle B. It's given here information when the particles are at the same height. At the same height means in between this part, the distance in between this particle move up and this particle move down. So to be in between exactly, this distance is 1 and this distance is 1.75 will be in the middle. So let's subtract first 1.75 minus 1. So the difference is 0.75 will be in the middle. So divided this value by 2 will be 0.75 divided by 2 will be 3 over 8, exactly 0.375. So they meet at this point. This point exactly up and down 0.375. So the height from the ground when this particle move up and move down will be 1 point when we add it to 1. So this height now is 1.375. 375. Now, before we'll get the velocity when this particle moves down, I will get its velocity, and same will be same for the velocity. Let me start now with particle A. With particle A. Particle A starts from rest and move down with acceleration is equal to 3. Move a distance is 0.375. You can find time and you can find the final velocity. The final velocity, v squared equals u squared plus 2as. If you want to get time, v squared equals u squared plus 2as. The final velocity, initial 0, 2 times acceleration 3, displacement 0.375. Then by taking square root. So 2 times 3 times 0.375. So the answer is 2.25. Square root for this answer will be 1.5. So the velocity is 1.5. What else you can find the time taken? So v equals u plus at. The final velocity 1.5, initial velocity is 0, acceleration 3, time is t. You can find the time taken before start to break is 1.5 divided by 3, so the answer is 0.5 seconds. This is exactly same for the particle B. Before the break, exactly same. Take the same time and the same velocity. Now, we'll start both same level. The level from the ground is 1.375. Now at the same time. But for this particle, move down. But it will start a new journey with its velocity 1.5 and the acceleration with gravity positive 10 and the displacement is 1.375. You can find the time taken to reach the ground. If you use for particle B, I'm talking particle B, this particle, because it's moving, sorry, for particle A, particle A. This is for particle A. Particle A continue to move the ground. You can find the time taken to reach the ground. For particle A, I will try now to find the time taken to reach the ground. You can use S is equal ut plus half of at squared. The displacement is 1.375 is equal initial velocity 1.5 multiplied by t plus half of a negative 10 times t squared. By solving this equation will be 5t squared, this part, minus 1.5t plus 1.375 is equal to 0. Mode 5-3 can solve this equation. 5 equal negative 1.5 equal 1.375 equal. You will get the time. I will repeat again. It's a 5t squared minus 1.5. 5 equals negative 1.5 equal 1.375 equal. I will start to look at this part again. 7s equals 1.375. 1.375. Okay. 1.375 is equal, u is 1.5. Yes, it's my mistake here. Acceleration is 10. So sorry. So this equation will be negative. I will correct this part. It's 5t squared plus 1.5t minus 1.375 is equal to 0. By solving this equation, now 5 equal 1.5 equal negative 1.375. So the time now is 0.395. The second one is negative rejected. So the time taken to reach the ground is 0.395. What about particle B? Particle B first continued to move up because of inertia. We'll start to use initial velocity 1.5. Acceleration is negative 10. And the stop for V is equal to 0. I will get the time taken to reach to the maximum height for this part. It will take a long time for particle B. Particle B, because we have two steps. Start to move up, continue to move up because of inertia. Its initial velocity 1.5, acceleration is negative 10, and the final velocity is equal to 0. V equals U plus AT. So the final velocity is 0, initial velocity is 1.5, deceleration is A times T, so time is equal to 1.5 divided by 10. 1.5 divided by 10, so the answer is 0.015. So T is equal 0.15. And also you can find displacement. S is equal UT plus half of AT squared. So the initial velocity is 1.5, displacement time is 0.15 plus half of negative 10 times 0.15 squared. So S is equal to 1.5 multiplied by 0.15, then plus half times negative 10 times 0.15 squared. You will get your answer 9 as a decimal is 0.1125. Now, the particle B between the ground, it was 1.375. If you remember this distance, 1.375, correct? Then, because of inertia, move up more, 0.1125. Then now start to move the ground. To get this time, we find the time is 0.15. Then start again from this height by using this distance. If we add it, plus 1.375, so the distance between the ground and the particle is 1.4875. So when it is moving down, initial velocity now is 0, acceleration now is positive 10, but displacement is 1.4875. Now we'll calculate the time. S is equal UT plus half of AT squared. For the displacement is 1.4875 is equal initial velocity is 0, then half of acceleration 10 and time is squared. By solving this equation, half of 10 is 5, divided this value by 5, then square root for the answer. You will get the time is 0.5454 to reach the ground. So now, what is the difference in time? The total time for this particle, total time, the total time is equal 0.5454 plus the time taken to move up because of inertia, 0.15 plus 0.15. So this time is equal to time is 0.6954. He asked to get the difference in time. The difference in time, 0.6954 minus the time found for the first particle, which is to reach the ground. Yes, this 0.395, 0.395. When you subtract minus 0.395, so the final answer is 0.300. Correct 2, 3 significant figures, so the difference in time will be 0.3 seconds. That's it. Thank you.